All right, we're going to do section 9.1, page 445, number 23, which reads, draw a graph of the sequence AN. And for this problem, AN is equal to n over n squared plus 1, and n is 1, 2, 3, up on to infinity. Now later in this lesson, you are going to watch a video on how to graph a sequence. And that video has a much fancy calculator than I have. But I just wanted to try to walk you through the basic steps now, and then know that you can watch that video at any time if you need a little more help. So the first thing that we need to do to graph this sequence is make sure that your calculator is in sequence mode. So you want to press the mode button, and that brings you to a whole bunch of settings for your calculator, whether you're going to use normal notation versus scientific notation versus engineering notation. And about 4 lines down, you see func for function, par for parameter, pol for polar, and seq, S-E-Q, for sequence. So you want to arrow down and arrow over so that SEQ is highlighted, and then you want to hit enter and use second mode to quit out of there. And now we're ready to do our graphing. So we almost always start graphing by hitting y equals. And when you do that, the screen is going to look a little different from the way it usually does. And the first line in there is going to say n min is equal to 1, and you can leave that the way it is. The second line is where we're going to enter the formula for our sequence, and it says u of n is equal to. And we're going to type in the general formula in there. Now your first question should be, how am I going to type in an n? Well, it's a variable. And we always use this key right here that says x, t, theta, and n when we're filling in variables. So if you press that key, an n will appear. And that's fine. That's exactly what you want. So we're going to type in n divided by, we're going to have to use parentheses to make n squared. We're going to press that n key again and hit the squared key, plus 1. Close your parentheses, hit enter, and really you can leave everything else on that page alone. So now you can just hit the graph button. And you may need to adjust your axes so that you can see the points in the sequence, and they're all going to show up as dots. I think when you're trying to get a feel for what the graph is going to look like for the behavior of the sequence, you probably want to go from n equals 1 to n equals 10. So you can use the window button to set what your x values are going to be. And in this case, actually, it gives you an n min and an n max. And you probably want to set n min equal to 1, n max equal to 10. And then you can go down and set x min equal to 1 and x max equal to 10. And then you want to figure out what you want your limits to be, your min and your max, in the y direction or the vertical direction. And for that, you want to look at this general term for your sequence. Now we can see that the denominator here is going to grow bigger than the numerator. It's going to grow faster. It's always going to be bigger. So the first term, the first element in our sequence, is going to be the biggest. So if I substitute in n equals 1, I'm going to get a half. And I know that every term after that is going to be smaller. So when I graphed my sequence, I graphed from 1 to 10 on my horizontal axis and 0 to 1 on my vertical axis, and knew that my first point was going to be up here at 0.5, and then everything else just kind of gradually worked its way down to the horizontal axis. And that's really all this problem is asking you to do.